Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zakiruddin, and today I will demo my project, which is design and simulation of buck converter using fuzzy logic controller. As you can see here is my signal builder block, which will produce the input voltage based on my parameters, which is 10 volt of input voltage. And here is the MOSFET block, which controls the circuit. And here are my inductor block, where it has 525 microhenry, and this is the diode block. And here is my capacitor block, which has a value of 60 microfarad. And to check the robustness of my controller, I had introduced a load disturbance in my circuit. Then instead of using resistor, I use an ideal switch, which has a value of 10 ohm, and the second ideal switch also has a 10 ohm. The first switch will on at 0 second, so we'll make the load in the circuit to become 10 ohm at start, and then at 0.03 seconds the second switch will on, thus changing the load from 10 ohm to 5 ohm, and then at 0.06 second the first switch will turn off, thus making the circuit back to have a load of 10 ohm. So to sum up about the load in the circuit will have 10 ohm at start, and at 0.03 seconds the load will drop to 5 ohm, and then at 0.06 second the load will rise again at 10 ohm. And here is my voltage reference block, which has 5 because my voltage output that I want is 5. So here are the voltage reference. The output of this block will become the error, and the array will go here, and then it will go to the memory block, where it will store the previous time instant of the array. And after that, from the output of this block, it will become the change in error. After the error and change in error had been input into the fuzzy logic controller, the fuzzy logic controller will output a desired duty cycle, where the small change of the duty cycle will then add up again and again, and then it will go to the PWM generator. The PWM generator then will produce a pulse which will depend on the duty cycle, and the pulse will control the buck converter. As you can see, here is my fuzzy logic controller. This one is the error, change in error for the input, and the output will be the output duty. And for my fuzzy logic controller design, I've used a triangular type for error, change in error, and also for the output. And here is where I change the combination of error and change in error to the output based on my design fuzzy logic rules, which is I'm using 5 membership function, so there will be 25 rules. After I have run the simulation, I check the output voltage scope, and as we can see from the scope, the output voltage is maintained at 5 volt, and once the load disturbance kick in at 0.03 seconds, there is a small ripple, and then the fuzzy logic controller will react to it to make sure that the output voltage becomes 5 again. and then at 0.06 seconds, once the load disturbance will be turned off again, a ripple also will be occur because there is a change of load, and at this time the fuzzy logic will again adjust to produce a voltage of 5 volt. And for my current inductor, current inductor, at start the current will be at 0.5, and then at 0.03 seconds the current will go up at 1, and then we go down again at 0.06 seconds when the load becomes 10 again, 10 ohm. Thus the current at the inductor becomes 0.5. I think that's all for my demo video. Thank you.